I will explain a for loop, which is used to iterate over a sequence such as a list. The for loop executes a set of statements for each item in the list and stops at the end of the sequence. I will use a for loop example from a code block that creates a line graph that shows the retreat of the Columbia Glacier in Alaska from 2015 to 2019 using transects to measure the retreat. We create a list of numbers from 1 to 23 that corresponds to the number of transects. This section of code specifies the color map that we will iterate through to assign colors to our transects. To plot each transect, we will employ a for loop. A for loop is a good choice here because otherwise we would have to write out the same code 23 times, once for each transect, in order to add each transect to our graph. If we utilize a for loop, we only need to specify what we want done once, and the code will iterate through all the transects in a loop until each one has been added to the graph. First, we iterate through the members of the numbers list. The argument enumerate returns a pair of values. One is the index, which is transect, and one is the associated value. By default, Python starts with the value of 0 unless you specify otherwise. Here we specify that the columns start with 1 by writing transect plus 1. If we excluded this line, the code wouldn't run because there is no transect 0. However, transect is a number at this point, and our column names are actually strings, even though they superficially appear as numbers. We therefore need to stringify the number 1, so we specify that a new object, column, is the stringified version. Python wouldn't recognize the number 1 in this context if it was an integer because the column headings are strings. The next line filters our data frame. We only include the data from our transect columns that fall within our desired date range, which is specified with a Boolean statement, i.e. if it's true that the data falls within our specified dates, we will include it. If we excluded this statement, we would get all dates plotted on our graph. Y1 therefore ends up as a data frame with 23 columns and as many rows as there are values that correspond to our date range. C equals next color refers back to the color command to make every line a different color based on the color map. Finally, we plot our data using the X and Y1 data frames. The name of each transect in the legend is defined by the column object, i.e. transects 1 through 23. The line width of our lines on our line graph is 1 and the colors are defined as C. We can change these parameters we wish to make our graph look different. We add a line of code to plot the average transect extent on our graph as well, set some plot parameters, and then show the plot. In our second example, we are looking at a code block that plots an ocean shapefile in the Vancouver region. The first line sets the Mercator projection as default using the Car2P package. The next line specifies the size of the figure, then that the axes should be plotted using the default Mercator projection. Next, we set plot parameters, such as the extent of the axes using predefined longitude and latitude values. We specify our coordinate system is geodetic. Line style specifies adding grid lines to the plot. In the for loop, we are iterating through the geometries in the ocean shapefile. My feature is the variable that takes on the geometries in each iteration of the for loop. The only statement to be executed in this for loop is to plot the shapefile geometries. Ax.addGeometries adds the spatial information from the shapefile to our plot. The plate carré projection treats the Earth as a flat plane on which our shapefile spatial data is projected. It differs from the Mercator projection because the Mercator projection treats the Earth basically as a sphere. Face color specifies the background color, and edge color specifies to edge the land, and alpha specifies the transparency.